Everyone, so we have completed the trapezoidal. So this one is completed. After that, trapezoidal, composite trapezoidal seems on this one, so only this Newton course is remaining. Okay, so this is, I told you that this is related to Lagrange formula that you have learned in Lagrange interpolation, right? So let's recall that one. So basically you have seen there maybe the node point may be different, like it is not that equally spaced node. Okay, like their point may be x1, x2, xr, this type of thing. Okay, so basically there you have seen if you have the corresponding value f of x1, f of x2, f of xn, then you can define the Lx function or Lagrange polynomial by r is equal to 0 to n w of x f of xr by x minus xr into w dash xr, right? Where you can say where w of x is what, that x minus x0, x minus x1 up to x minus xn. Similarly, w dash x you can find, right? So this is, you have the corresponding expression for your polynomial, right? Now suppose, so this is your approximation of your fx, right? You are writing your exact function fx by this polynomial. So you have a look there, that Lagrange polynomial, where it is discussed, what are the error, all this type you can see there. Now what is your job in numerical integration chapter? Basically you have to do I is equal to integration a to b fx dx, right? So here if you substitute that expression, because this is also a closed form of Lx, so if you use this, so you have a to b w of x f of xr by x minus xr into w dash xr dx. Alright, so here you will see I can write this thing as, there is summation. Okay, this summation and integration is, you can change, that is they are commutative. Okay, so this type of thing already you have seen in series of obviously this is finite sum, so no problem there. So r is equal to 0 to n a to b so this thing I can write as f of xr into hrn. Okay, r is running from 0 to n. So what are the expression of hrnx? So a to b, you see, w of x, this is written already by x minus xr into w dash xr, right, and dx. So this is your expression. Okay, so this is already you got. Now what is happen in Newton course? Newton course, whenever you are applying, this will be equally spaced. Okay, now I am going to Newton course. So this is from your, you can say from Lagrange interpolation, right? So this thing you can write using formula, right? Now I am going to the Newton codes. Okay. So here your note are equally spaced. So let x0 equal to a, then your x1 will be x0 plus h dot dot dot, xn will be a plus nh, that is your b, right? Okay, so then you have to find this type of thing will be equally spaced, then you can use some nice form. Okay, so let's do this. So then basically you see you have to find this hrn in terms of equally space, right? Then hrn is your a to b w of x dx by x minus xr into w dash xr. Okay, so if you substitute this, so this is your x0, this is your, you can say x0 plus nh, right? Okay, now you consider a substitution. Let x equal to x0 plus ht. Okay, so then already you have done this type of calculation. So what is your x minus xr? So if you substitute this thing, so x0 plus ht, and what is your xr? x0 plus rh. So you can have that t minus r into h, right? And what is your dx? Dx will be h dt, right? Okay, now if you each term we are finding, so this is already fine, this is fine. So what is your wx? So w of x is your x minus x0, x minus x1 up to x minus xn. So if you substitute all this thing, so using this type of relation, so r value is 0, so that means it is th. Next will be t minus 1h, right? Then in this way you have t minus n into h. So how many h is there? So you will see there are n plus 1h, right? And all the other term is like that. Okay, now already earlier you have seen what is your w dash xr. Basically you have to derive it and differentiate this thing. Basically this is a product formula for all n plus 1, right? So there, after that, whenever you are substituting that xr, only one term will be there. So this thing you can look in the Lagrange interpolation chapter. So from there you will see you have this type of expression. xr will not be there, right? Because if it is there, then it will become 0. So what you have? So this will be your xr minus x0. So basically just rh, right? Next one will be r minus 1 into h. So this will be your h, and then next one will be minus h, right? Then you have minus 2h and so on. You have minus n minus rh. Basically this is r minus n, right? So I am writing in that form. So how many h will be there? Basically this is n plus 1. So if you see their count the term, so there will be h to the power n. Think why one less. Okay, and you see r minus 1 to up to 1. So this is r factorial, and here you have n minus r factorial, right? But there will be some minus 1 whole to the power. How many minus is there? So there is a n minus r, right? So together with you are getting this form. So each term we have find. So what is your exact form now? hrn. So therefore, so you have a look all the thing. You have to substitute in this expression, right? In the w x expression already we have find x minus xr w dash xr dx. Okay. So therefore, okay, have a look, carefully substitute each term. Okay, so which term is independent of t? So I am taking outside the integration. You see, if you cancel this, h only remaining, right? So what is left in the integration? Okay, so this is the expression. Okay, now you know h is basically b minus a by n, right? A by n, if you write b minus a by n, n I'm writing next part. Okay, I can copy all the thing. N, right? So this thing I am writing as b minus a into k rn. Okay, so where k rn will be what? All the expression you have to write. Okay, krn is your, you have to write n here. Fine. Or obviously b minus a equal to nh also you can write, no issue. So this is the expression. Okay, so now what is the form you are getting now? So this is, you have a to b fx dx would be your b minus a into summation you see. We have fxr in that expression, right? That also you have. Now we have find that hrn will be b minus a into krn, right? So fxr is there. So b minus a already we have written. So f of xr krn. Okay, so this is the expression. So basically here no problem will come, like some computational problem. Most of the cases there is asked some theoretical question. Okay, like earlier you have seen in Lagrange also there is some theoretical question, that summation, what are the value of summation w xr or something like that. Okay, so here also you have this type of thing. Anyway, so what are the error here? So error is your a to b w of x so earlier you have seen what is your rho n plus 1, that is your wx into f of n plus 1 child type of thing. So here you are doing integration, so you have to write that dx thing here. Okay, so this will be your x0 to x0 plus nh x minus x0 x minus x1 dot x minus xn. Sorry, here you have writing n plus 1 factorial also. Okay, so again if you use your previous transformation, okay, so then you will get this thing here, h times 0 to n. Okay, this will be h to the power n plus 1. This h coming from dx equal to h dt from there, t into t minus 1 dot t minus n divided by n plus 1 factorial and f of n plus 1 chi dt. Okay, so this is the form. Anyway, now what are the type of question comes in your exam? Okay, so problem, suppose first problem is your summation hrn, what are the value? Okay, so this value, if you see, this value will be b minus a or nh. Okay, so how to prove? So basically you know that wx into x minus xr into w dash xr equal to 1, right, for r equal to 0 to n. So if you do the integration of this, okay, what you will get? A to b, the same expression, obviously here you will get b minus a, right? So what is your hrn? This thing, right? So that's it. Now if you use your substitution, then you will get a different part, and that is no problem. So basically this is your summation HRN, right? This is your B minus A. Next problem is, suppose they ask what are the value of summation KRN. So you just use your expression, because you know this is equal to B minus A into HRN, right? So this is, you know, B minus A, right? No, KRN, HRN equal to B minus A KRN, right? So what is KRN? This type of thing. So B minus A by A, because upper sum is this, so in this way you will get this. Okay, next problem is, suppose they ask, prove that HRN will be Hn minus R into N. Okay, so here basically you have to, already you have the expression for HRN. Okay, suppose you are using in your that with substitution form. Okay, so what is your HRN? So that you can write, right? You know HRN is your minus 1 whole to the power RH by n minus r factorial 0 to n t minus 1 dot t minus n divided by t minus r, basically, dt. So you have this thing. Now what you will do, you use here n minus r. So what will change here in this expression? Instead of r, you have to write n minus r, right? Okay, now you just think here, you have to use another substitution, u equal to n minus t. Okay, then complete the remaining part. Okay, then you will see after some line that this will be your HNR. So this is your homework, maybe 4. Okay, so similarly you will get KRN will be KRN minus RN, because you know that are related with just B minus A, right? That's it. Okay, so this is done. Now if you use your expression earlier thing, so suppose they ask fifth one, find K01. So use your expression, just substitute the value n equal to 1 and r value is your 0. So from there you will get minus 0 to 1 t minus 1 dt, right? So if you use, you will get the value. Okay, so similarly your homework 5 is find. Okay, similarly if you find suppose K31, so from there you can say K32 will be the same, right? Because using this formula. So this type of trick you have to use. Okay, so suppose your job is to find K4 1, K4 2, K4 sorry, from 0, 0, 1, 2, K4, 3, K4, 4. So you see, if you find these 3, then everything will be done, right? So this is the thing. Okay, I stop here. So this is your last portion. You have a look at the book, all the portion. Okay. One more homework I am giving you. Just have a look. This. Homework 6. Find -1 to 1, or not find, proof fx ds equal to 1 by 3 f of -1 plus 4f of 0 plus f of 1. Okay, so this type of formula you have to find from the first class, that quadrature one. Okay, so you have a look, can you able to solve this? Okay, otherwise we will discuss in our offline classes. Okay, bye for today. So after that we have only one more chapter, that OD1. So then we'll go to the numerical practical. Okay, bye.